Yeah, I'll probably have to re-record this because I'm making too many mistakes. Hi there. Today let's tackle another exercise in the Nature of Code book. And we're looking at exercise 0.3, create a random walker with dynamic probabilities. For example, can you give it a 50% chance of moving in the direction of the mouse? Remember, you can use mouse X and mouse Y to get the current mouse position in P5.js. So I would summarize this as a random walker with interactivity. So essentially, I will use mouse X and mouse Y in order to direct the random walker so it's moving toward the direction of our mouse. Let's open our P5 web editor and let's start by implementing the random walker again. That is going to be a review. Since I covered in the previous episode, I'm going to go relatively quickly. And in order to I'm going to create a walker class. And it actually doesn't have parentheses over here. So class walker, and then I need a constructor, which will taking the initial position x and y, as well as the step size, and this dot x equals to x, this dot y equals to y. In the previous episode, I was calling it init x, init y. That doesn't really matter. And essentially, what we are trying to do here is to passing the value for the walker so that we can assign the initial x and y coordinate, which will then be associated to the walker itself with this dot notation. And let's create the step function, which will step to some direction. And then the draw function, as always, I always like to create the draw function first so that we can see what's happening on the canvas. I'm going to draw a dot or a point which has arguments x, y, and that's all I need really. And I'm going to run the code just to see everything works fine, and creating a walker here. And in the setup, I can create a new walker that's starting at the center of the canvas and step size 1. And inside of draw, I'm going to call walker dot draw. Again, there should be a tiny walker right there. And then let's try to implement this step. As a regular random walker, we're going to have roughly equal probability. I'm going to start with a random value that is generated with a random function. If this random value is larger or smaller than a quarter, which is 0.25, I'm going to move to the left. So this dot x move to the left. So decrease the x, and else if random value is smaller than 0.5, I'm going to move to the right. And then random value 775, going to move to I'm going to move y in this case. Step size, so move I'll start just to be consistent, kind of follow the same format as I had in the before. And then in this case, I'm going to move downwards on the y-axis. So now I just created a random walker, but I haven't called the step function yet. I'm going to call it right here. So now you can see the walker. What did I do wrong? Step size is not defined. Right, of course, I forgot this dot. So I'm going to do Command D on my Mac, or you can do Control D on PC if you're on a PC. And to select the first keyword, Actually, let me repeat that. So I'm selecting the step size, and as I hold down Command key and D and D and D, it will select all of them at the same time, and then I can edit all of these at the same time. So this dot step, and now it should work. And it's moving around without, I know it's a little hard to see for now, but let's move the background from, where is it? Move it right here. I'm going to delete it here and put it in setup background. And in fact, I'm going to change that to a white background. So now we just recreated this random walker with our first 5 minutes or so. And now, how can I make it interactive with the mouse? First, I need to basically, I will be using the mouse X and mouse Y, but how do we calculate that relative position? Let's see. So essentially what we want to do is increase the likelihood to move toward the mouse. So what we're going to do is, if the likelihood right now is actually like with the current format, it's not super easy to adjust. It's because once you adjust one of them, it kind of a lot of thing kind of happens. So I think one thing we can do is to separate them first. Let's separate all the conditions so that they're not affecting each other, because right now, even though this is relatively a concise way to write this random walk, it's actually really tricky to change one probability for one and then without affecting the other one. So I'm going to separate them so they're somewhat independent. And let's separate by X and Y. Going to remove it here. So now this is separate. And when they're separate, oops, we can then and actually, why don't we, yeah, when we are separating this, why don't we also separate the random value? Because right now, so basically right now, if what I created right now is, oh, that's no, shouldn't be there. So what I just created is a random walker that will either go to the top left or the bottom right, which is not good. And this is happening because this random value will either be smaller than 0.5 or larger than or equal to 0.5. So if it's smaller than 0.5, both on the x-axis it's going to go to the left, and on the y-axis is going to try to go to the top, and that's kind of what happens. But we want that to be separate. So one thing we can do is to generate a new random value. So in this case, I cannot use a const since I'm going to reassign the value. And what I can do is change random value here equals to random. So now they're independent. This is something you just created. I also noticed one thing that I didn't see before. Oh, so there's definitely still some kind of artifact, because it's always moving diagonally. So the two are moving at the same time. Huh. That's also not great, because essentially we only want to move once. We only want to make one step, because what's happening right now is going to move both X and Y. So this approach actually isn't going to work. Huh. But this is also a fun effect if this is something you want to create, but that's not what we're trying to do here. In that case, let's I didn't think this through. If if mouse X, if it's on the right, so let's increase the probability to that direction. This is actually trickier than I thought. Now I'm like on the spot. Mouse X, if mouse X is larger than X, should be more likelihood to move to the right. And okay, so let's do this. I'm going to undo a bunch of steps and go back. Oops, leave it there. So this is kind of I'm going back to a regular random walk, a traditional random walk, a random walker. And now, really, what we can do is to divide, because right now it's nicely organized so that when the random value is smaller than 0.5, X will change. When the random value is larger than or equal to 0.5, Y will change. So really, we want to keep this 0.5 equal, like if we want X and Y to be the same probability. And we will use the mouse X and Y, the relative position, to affect this number, the 0.5 here, because this is where it adjusts the likelihood between the left and right, and this is where it adjusts the likelihood between top and down. So let me show you an example. So if I change this probability to 0.1, then suddenly there's a more likelihood to move to the right. And if I change this probability to 0.6, and then there's more likelihood that's going to the bottom right now. So the second number that I change is to increase likelihood to go to the bottom, which is the exercise that we did in the previous episode. And now, if we want the likelihood to, if we wanted to move towards top right, then we are going to make this number 0.9, because there's a larger portion in the likelihood of Y going upwards. So with that in mind, we can use the mouse position, add a mouse position in here. So if we can either combine, let's see I'm trying to think of a way that's both works and also easy to understand or read. So let's add it in here. If mouse X is larger than the current X, then there should be more likelihood that it's going to the right. So I think we can leave that there, because in this case there's more likely to move to the right. Or I'm going to be combining some probabilities. Or if mouse X is smaller than or equal to X, then random value, this probability becomes let's see, like 0.4. I'm not sure. I mean, yeah, I'm not sure if this will be easy to understand. Maybe I need to think about this and make a different video. Or maybe it's fun to watch me struggle and come up with a solution. Let's see what I'll decide. Let's do this one. So similarly, if first condition, if mouse Y is larger than this dot Y, and random value is smaller than, yeah, like I mean, it works, but it's really not the most not the easiest thing to kind of understand or easiest thing to kind of read, in my opinion. There must be a better way. Oh, not random y. So if mouse y is smaller than this dot y, and random value is smaller than 0.9, let's see. So 0.9, that is more likelihood that we're going to that direction. Yeah, I think so. So now let's try this. Yes, so let me move my mouse here. Yeah, it's going towards my mouse. So that's what's happening. And so there's more likelihood it's going to the direction of my mouse. Yeah. So that totally works. And the only thing is I'm not happy with how it looks. It's really, it's, yeah, I wish yeah, I really need to think about what would be an easier way, what's a better way to arrange this so it's easier to read. Um, yeah, maybe mouse X. Yeah, let's rearrange the if statements. Yeah, I'm going to, why don't I keep this version? I'm going to duplicate and I'm going to create a version 2. And in the version 2, what I'm going to do is to rewrite these if statements. So I'm going to delete the if statement. Let's try to rewrite this. So let's separate that by the x change and y change. So if random value is larger than 0.5, or let's start maybe smaller than, if it's smaller than 0.5, we are going to make some changes on the x. And else, we are going to make changes on y. And we can label this. So move horizontally. And this is going to be move vertically. Yeah, so that's how we separate them. And then now inside here, if mouse X is larger than the current X, then let's make it more likely to move to the top. If mouse X is larger than X, then it's moving to the right. Yeah. So and then random value. So now if you think about random value, it's really a range between 0 and 0.5. Or maybe should I introduce map here? That's probably going to make it more confusing. So let's keep it like this. So if random value is now if it's larger than, or if it's smaller than if it's larger than x, so that means mouse is to the right of the current x, then there should be more likelihood. So 0.4. So 0.4 is like 80% of, yeah, basically 0.4 is the majority likelihood of the what's really a better good way to make this look. Yeah. I think this is improvement from the earlier version. So right now we know that within this if statement, this random value is already, we know that's smaller than 0.5. So from a number from 0 to 0.5, if this random value is further smaller than 0.4, which is because it's either between 0 to 0.4 or it's 0.4 to 0.5, so there's more likelihood that this is going to happen. If that happens, then this dot x increase by the step, and else it should decrease by step? No, else if there's less likelihood. So mouse x is smaller than this dot x, and random value is smaller than 0.4. Or, oh, yeah, having some new ideas. Yeah. The thing is, it's also not really a good idea to have too many nested if loops, so that also make things hard to read. So let's see how I'll like this. It's been how long it's been? It's been almost 20 minutes. Not great. So if in this case, let's define. I'm even going to further improve this by defining the likelihood. Yeah, the likelihood for moving the bias towards one direction or the other. Or let's not worry about it now. So this dot x, or yeah, if random value is further smaller than 0.4, then that means this is a more likely scenario, but this will depend on whether mouse x is larger than this dot x, then this dot x should move toward the mouse x, which is going to be this, and else it's going to move towards the opposite direction. This dot step size, and else I'm really not sure if I improved this or yeah, I'm really not sure if I made it easier to harder to understand, but this is an alternative solution, I guess. Mouse x is larger than but then I want the opposite. Yeah, I really don't like how this solution looks. Maybe I should have just kept the original solution. Or maybe I shouldn't, or maybe I should have thought this through and prepare instead of doing this live and leaving all these kind of struggles in here. I'm really not seeing necessarily a solution that's easier to like, that can be more easier to read. Let me undo some stuff. What did I have earlier? Maybe this version is good enough. Did I even no, I didn't even finish typing this one. So this dot x going to move toward the opposite direction of the previous one. And similarly, if mouse y is larger than this dot y and random value is smaller than 0.9, this dot x or this dot y is going to move towards the, yeah, these are step sizes. I keep mixing this. And else if mouse y is smaller than this dot y, and also I'm not, yeah, this should be like smaller than or equal to, so that they are, yeah, so that they cover all the possibilities. Random value is smaller than 0.9. This, of course, this should be the closing brackets. This dot y should move to the other direction. Let's try this again. I think it's, yeah, it still works. But I don't like either of the options. And it's also kind of too much. I'm almost direct, and this doesn't feel like random random walker anymore. So I'm going to adjust the likelihood. So instead of 0.4, I'm going to change it to 0.3. So now it's like a 60 versus 40% chance. And this is going to be 0.8. This is to increase the randomness a little more. And yeah. You know what? This is still. Did I run this? How come, yeah, the likelihood still feels very much goes towards the mouse. So let's make this, yeah, let's make this even smaller, the difference. So 27, 27, and this is going to be 77 and 77. Let's see what is going to happen. Okay, I think maybe that's okay amount of randomness. Let me know what you think down in the comments, or if you have a better solution, please post it in the comments, and I'd love to learn from you. And as always, I think this is where we've come up with a solution. If I think of a better solution, I'll post another video. But for now, let's do something fun with this. And I'm going to duplicate this again. Interactive walkers. The simplest way to make something like this interesting is always to create multiple of them. That's at least a really simple way to do that. So I'm, instead of one single walker, I'm going to create an array of walkers, and then also I need to specify the number of walkers number 10, and I'm going to create a for loop. Let I equal to 0, I smaller than walker's number, and I plus plus. So this is the for loop. Again, this is something that I covered in the previous video, so you can check that out if you want more details. Walker, so let's create a temporary walker here and add walker to the walker array. So they're all starting from the center. And similarly over here, I'm going to use the same for loop. I equals 0, I smaller than. This time, instead of walker's number, I can also just use walkers dot length, which get the length of the walkers array. There's, in this case, there shouldn't be any difference, because these two numbers should be the same. And then I can, what I can do is to either create a separate walker here to kind of access that specific walker, and then so I can then call the walker.step and walker.draw. And this should be it. So now we have 10. So when we have 10, we kind of get to see how different possibilities are emerging. And let's also increase the number. 10. Yeah, so this looks like some roots, growing roots. But when they're all the same color, you can't tell the differences of different walkers. So let's like what we did last time, let's add color to this. And this time I'm going to add something more colorful. So let's add random 255, random 255, random 255. So essentially I'm using the RGB to control the color, and I'm assigning random values for both for all three values R, G, and B, red, green, and blue. So now it's going to create any kind of random number. And then I need to use that random number when we draw this point. So that is going to be stroke this dot color. And let's see what it looks like. Yes, random colors that are growing. And we can also, if we want to be more specific in terms of the color choices, one thing we can do is to use the HSB or HSL mode, so I can change the color mode to HSB for brightness, hue, saturation, brightness. So now the range is going to be, the hue is 360, saturation is 100, brightness is also 100. But this way, this would produce relatively, interesting. Yeah, maybe the HSB is not registering properly. Color mode. Is it using that color mode over here? Yeah, when you create color, can you change the color mode for that? Or is it, yeah, it should be here. This is where it changes the color mode. Does it also change? Yeah, maybe, yeah, changes the color mode there. Let's try something. So 0 should be red. Okay, so it is working. It is certainly working. And so once we are using the HSB, we can then specify the kind of color we want. Let's say if we want something in the around the red range, that's about 0 to 30. And then in terms of saturation, we want it to be super saturated. So let's see, 90 and 100. And if we want the brightness to be like fairly bright, 90 and 100. So now we're going to have bright red. And it's a little too bright and can't barely tell the differences between the reds. And maybe if I want to resemble, yeah, I think I like the bright colors, but just make it a little less extreme with 50. And also, just to add a little more variation in color, I'm going to add this up to 60. Yeah, so there's a little more variation in the color. And I think 100 is such a small number. Let's change that to 1,000. So we have so many different color variations. And then we can draw, and we're essentially kind of guiding these random walkers, these 1,000 random walkers, along the line of our mouse. We're using our mouse to guide these random walkers. Somehow, it still surprised me that this very little change of the randomness. I think I want to further change this to maybe 6. That's like a very low likelihood that I'm surprised that most of the time it's still moving toward the direction of my mouse. Save this, run the code. Oh, and this is a particular, yeah, because it's like the same. So when it's on the same, oh, interesting. So there must have been something, maybe there's something that's done wrong, because when it's at the same point, it actually barely moves to the right or to the left. Maybe I did something wrong here. So if random value is smaller than 0.5, and x is larger than x, smaller than that. If mouse x is larger than that, then we have this likelihood. Step size. Can't really see an issue here. But somehow it doesn't go beyond. It should still be able to go to the other direction though. So if x is larger than x, then there's more likelihood that it's going to this direction. Oh, I made such a huge mistake. So when x, I see, so basically when random value is larger than 0.26, it kind of doesn't move anywhere. That's also why it's moving so slow. This, I messed up big time. This is not great. This is not great. Um, this is a bit embarrassing. I think I should change this to, okay. So we actually need if and else. So maybe one of the solution earlier will kind of work. Yeah. If and else. So yeah. This is, I think this is only getting messier. This dot x. This should be the opposite. Step size. This dot x should be then the positive step size. And I do not think it's easy to read at all because it confused myself quite a bit. And but let's see. I'm curious to see what it will look like now. That's why I was like absurdly following the line like quite accurately. Um. So if that statement, this, we're going to separate this. If here and else, in the other condition is we're going to do the opposite. This dot y is going to move to the top. And in this case, this opposite direction, this dot y is going to move to the bottom. Oh, I think this kind of goes back to the original one of the mistake that I made before. Interesting. What did I do wrong? I really need to reevaluate this. It's 37, yeah, 30 something minutes into the recording. I think I'm probably gonna, yeah, I'll probably have to re-record this because I'm making too many mistakes here. What did I do wrong here? Let me look at this again. Step, if the random value, if it's smaller than 0.5, and if the mouse x is larger than x, then there's more likelihood that it's going to that direction. I guess that should have been the opposite. But no. Yeah, this doesn't make sense. Yeah, this is kind of what I was saying, that it's really not super readable the way I'm writing it now. If it's smaller than 0.5, it's more likely it's going to move x. If it's larger than 0.5, it's going to move y. And now, or maybe you should move the x and y. Okay. Let me try to rewrite this again. And hopefully I got it get this right now. Yeah. So if mouse x is larger than the current x, okay. I think, yeah, the actually another solution, another way to do this that make actually I think of a way to make it more readable. We can split it into 1, 2, 3. We can split it, so instead of 4 different possibilities, I'm going to separate it to 6 different possibilities for the random value. So random value smaller than 0.1. Yeah, I'm thinking about how I can easily adjust these numbers. Else if random value is smaller than 0.2. Else if random value is smaller than 0.5. So still random value smaller than 0.6. Else if random value is smaller than 0.7. Okay, else 0.6 yeah, which essentially, yeah, when it's larger than that number or equal to. So now we have 1 condition, 2, 3, 4, 5, 6. And this condition, the first condition, has 10% of chance, which is going to be to move x to the left by step size. The second one is going to be move x to the right by the step size. I keep forgetting the size section part. And oh, and there's also another typo here. Now I'm just everywhere. And similarly, I mean, technically I can even, I don't even need 6. I just need 5 conditions. What am I even thinking? Yeah, let's just put it 3. This is actually also going to be easier to read. And so, and then, so I'm really doing the same thing that we did before with these possibilities. This dot step size. So the first 4 conditions are very similar to before. So if it's the first 10% of possibility, let's move to the left. And then the next 10% of possibilities, let's move to the right. And next 10% of possibility, let's move down. Next 10% of possibility, let's move it. Sorry, the previous one was moving up, and the fourth one is moving down. And finally, in the last case, we are going to move based on the mouse position. So there's basically 60% of chance that it's going to follow the mouse position. We can either add it in addition as an else if statement, or in this case, I'm going to write a separate if statement that's hopefully slightly better to read. So now if random value, this time we don't even have to worry about random value. So now if mouse x is larger than this dot x, we are going to this dot x. Oh, I guess maybe I do need another probability. Yeah, I guess I do need that extra probability. Yeah, that's why I was thinking about a 6 before. I keep changing my mind today. Yeah, let's keep typing this. That's going to move to the step size to the right, else this dot x is moving to the left. Okay, how many times do I have to change this? So now random value smaller than point. We have how many left? 3, so 7. And then else if random. I mean, this time we don't need else if. If mouse y larger than this dot y, else here we are going to move to the right to move downwards, and this dot step size. Okay, now I think now I just finally created what I intend to create, and this time it shouldn't stay in a single line. Or does it still? Yeah, I mean, yeah, it's not a single line anymore. I'm glad. So I fixed the problem I'm trying to fix. And now I can also adjust the probability. Earlier I had an issue with probability because I was not writing it properly. So 2, 4, 6, 8, 9. So in the 80% of the time, it's going to do just random possibility, but for the rest 10%, it's going to move toward the mouse. So this time the mouse has very little influence, but nevertheless it still does influence the overall direction, and that's something that's more present when we have a lot of the um, when we have a lot of those random walkers. And this also makes this looks more interesting, yeah, because we want that randomness. So now, based on just by adjusting these numbers, we can adjust the different possibilities. And I hope this finally the final version is what I intend to create, and it's to me it's a little easier to read, and I hope it's the same for you. And if you are still watching, I mean, if you're still watching, I'm really grateful. Thank you for watching me make mistakes and finally find the solution that I intend to find. And I hope you enjoy this video. And thank you.